Welcome to the deep dive. Today, we're really zeroing in on something critical for anyone prepping for the Salesforce Certified Agentforce Specialist exam.
Yeah, we're tackling the prompt engineering domain.
Exactly. And it's huge, right? It carries, what, 30% of the total weight?
A massive 30%.
Yeah.
That's Salesforce basically shouting, this is core. It's not just about, chatting with an AI.
No, it's about proving you can build these generative AI solutions so they're actually useful, secure, reliable, and properly plugged into Salesforce.
That's the key. That 30% tells you this is the skill they need specialists to have. You think about the whole setup, like the Einstein trust layer and the LLMs. The prompt is really the only lever you, as the specialist, have direct control over to shape the AI's output. It's how you turn this incredibly powerful, but sometimes kind of vague AI into a predictable, accurate helper in your workflows.
So our mission today is to walk through everything needed for that 30%. We're talking definitions, the architecture, the best ways to actually write prompts, how to feed it the right data.
And crucially, how to govern it all, the whole life cycle.
Right. And the main tool we'll keep coming back to is Prompt Builder. That's the low-code way Salesforce lets you build these complex AI responses without needing deep coding skills, unless you want to go there.
Understanding Prompt Builder is really understanding Salesforce's whole approach to generative AI, making it safe, governed, and accessible. So let's start right at the beginning. The architecture, the different types of templates, the foundation.
Okay, Prompt Builder. What's actually in a template? I've seen terms like ingredients, guidelines, grounding.
Think of it like a recipe. Seriously, the ingredients are your data merge fields from records, maybe data pulled using Apex, stuff retrieved using RJ. Exactly.
Yeah.
Then the guidelines, those are your instructions, how you tell the AI what to do, the tone to use, the format, the art of the ask we'll get into later.
Okay.
And grounding this is super important. It's connecting the prompt to trusted data, your CRM data, data cloud info, specific documents. This stops the AI from just making stuff up based on its general knowledge.
Right, prevents hallucinations. So Prompt Builder brings those three things together in a low-code way.
Precisely. Now, a key thing for the exam, and just for practical use, you build a template, you save it, but it's not live yet, is it?
Ah, the lifecycle point.
Activation.
Activation, yes. A new or edited template must be explicitly activated. If it's not activated, users can't see it, flows can't call it, it's just a draft.
So if you're testing and something's not showing up, first check, is it active?
Always the first step. And related to that, when you edit, you have two choices. Save as a new version or save as a completely new template. This distinction trips people up.
Why is that so critical? What's the difference mean in practice?
Okay, so saving a new version keeps the same underlying unique ID, the API name. If you have a flow or code pointing to that template, it'll automatically use the latest active version. No changes needed downstream.
Convenient.
Very. But if you save as new template, it generates a totally new, unique API name. You have to do this, for instance, if you're taking a standard Salesforce prompt and customizing it.
Oh, okay. But then the responsibility is on you to go update any flow, any code, any component that was using the old template to point to this new one. It's about whether you're iterating on the same reference point or creating a distinct new one. Huge implications for maintenance.
Got it. That makes sense. Okay, let's talk template types. They aren't all the same, right? Let's start with field generation.
Field generation. This one's pretty neat. It's designed to, well, generate text for specific fields on a record page. Think populating a product description or summarizing case notes into a short field.
The example in the prep material was about a resort, right? Taking a few basic details and generating a full marketing description.
Exactly. You feed it maybe the experience name, type, location via merge fields, and boom, it writes a compelling description for you. Saves a ton of time.
But there are specific technical requirements here, two big ones.
Yep. First, field generation always needs a human in the loop. It doesn't just happen automatically. The user has to physically click that little Einstein generate icon next to the field.
So user interaction is mandatory?
Mandatory. Second, and this is a major exam point, the Lightning record page absolutely must be using dynamic forms.
Why dynamic forms specifically?
Because dynamic forms allow you to place components, like that generate button, at the field level. Without dynamic forms, there's just no place in the UI to put the button for that specific field. It's a technical dependency.
Okay, so troubleshooting a field generation issue. Check activation, check permissions, and check if the page is using dynamic forms.
You got it. Now, contrast that with the sales email template.
Different purpose, different mechanism.
Totally different. This one's specifically for drafting emails, usually sales outreach. Think personalized emails, pulling in contact details, account history, that kind of thing.
And how does the user kick that off? It's not the same field icon.
No, it uses a dedicated button, usually within the email composer itself, labeled Draft with Einstein. It's built right into the salesperson's email workflow. Different button, different context.
Makes sense. Okay, the third one sounds like the most powerful, maybe the most complex. The Flex template. When do you need this one?
Flex templates are your heavy lifters. They're the go-to when you need to generate something based on data for multiple unrelated objects.
Unrelated objects, like not just parent-child.
Exactly. Imagine needing info from an opportunity plus details from a related custom object for, say, service history, and maybe even data from a completely separate custom object tracking project milestones. Things that aren't easily reachable with simple merge fields from a single record context.
So pulling data from all over the place.
Pretty much. And because it's potentially pulling and synthesizing so much complex data, you can't just run it by clicking an icon on a page layout.
Right, the execution is different. How are Flex templates invoked?
Programmatically, this is key. Flex templates must be executed via an invocable action. That means you're calling them from Flow, Apex, or the Connect REST API.
So automation is required.
Absolutely. When you call it from, say, a flow, you'll typically pass in collections of records, maybe a collection of opportunities, a collection of those custom service logs. The Flex template then takes these inputs, and your prompt instructions tell the AI how to weave all that disparate data together into the output you need. It's designed for these automated, complex data synthesis scenarios.
Okay, summarizing this foundation then. Prompt Builder is your recipe book. Activation is key. Field generation needs that human click and dynamic forms. Sales email has its own Draft with Einstein button. And Flex templates are for complex, multi-object data triggered only by automation like Flow or Apex.
That covers the containers. Now we need to talk about what goes inside them, the actual instructions we give the AI, the craft.
Right, the art of the ask. So we have the right template type, but how do we make sure the AI actually does what we want and does it well?
It starts with the basics. Clarity, conciseness, consistency. Your prompt needs to be unambiguous. You want to minimize the chances the AI misinterprets you.
The source material mentions something about, like, human cognitive limits. How does that apply to AI prompts?
Yeah, it's a good analogy. Remember that idea that humans can only hold about 7 pieces of information in working memory? While AIs are different, the principle holds. If you overload a prompt with incredibly complex nested instructions, multiple conflicting goals, you can actually degrade its performance. It struggles to track all the constraints and logic simultaneously. Simpler, clearer instructions often lead to more reliable logical outputs. Avoid prompt decay by keeping things focused.
So keep it manageable. One technique that seems simple but effective is role-playing. Just telling the AI who it should be.
It's surprisingly powerful. Starting your prompt with, "You are an experienced technical support agent specializing in network issues," or "You are a cheerful marketing assistant writing a promotional tweet."
It sets the stage immediately.
Instantly, it tells the model which part of its vast knowledge base to access, what tone to adopt, what vocabulary to use. It focuses the AI.
And didn't the stats show a big jump in usefulness, like 38%, just from adding that role?
Yeah, the perceived usefulness went up significantly in testing. It's such an easy win for getting the right tone and context, especially making sure the output matches your brand voice.
Low effort, high impact. Love it.
Yeah.
Okay, what if we need consistency in the format of the output or a specific pattern?
That's where few-shot learning comes in.
This is where you give it examples, right? Like 2 or 3 input-output pairs.
Exactly. You embed these examples directly into the prompt template.
Yeah.
You're not retraining the whole model. You're just showing it, when you get input like this, I want output that looks like that.
So demonstrating the desired structure.
Precisely. Showing, not just telling. The key trap here, though, especially for the exam, is making sure your examples align with how your actual data will come in.
What do you mean?
Well, if you're using merge fields to pull in live data, your few-shot examples need to mimic the format and type of the data those merge fields will provide. If you're classifying customers and your live data comes in as last purchase date, YYYMMDD, your example needs to use that same format, not just date, Jan 1.
So the example structure must match the dynamic input structure?
Otherwise, the model gets confused. It sees the static example formatted one way, the live data another way, and doesn't know how to reconcile them. Consistency is key.
Okay, makes sense. Now, what about really complex tasks? Things with multiple steps? Should we try to cram it all into one giant prompt?
Definitely not. That's where prompt chaining becomes essential. Think modularity.
Breaking it down.
Exactly. You take a big multi-step goal like summarize the case history, identify the root cause, extract action items, and draft a follow-up email, and you break it into a sequence of smaller, focused prompts. Prompt 1, summarize. Prompt 2, identify cause, using summary from prompt 1. Prompt 3, extract actions, using cause from prompt 2,
Yeah.
and so on.
And the big advantage isn't just maybe better quality, but it's easier to figure out what went wrong if it breaks.
Hugely easier for debugging. If that single massive prompt fails, you have no idea which step failed. Was the summary bad? Did it misunderstand the cause? With chaining, if prompt 3 gives you garbage action items, you can look back at the output of prompt 2. Did it correctly identify the cause? It lets you pinpoint the failure point much more easily. Critical for reliable automation.
Okay, chaining for sequential tasks. Now there's another technique, chain of thought, or COTE. This sounds related, but different.
It is different and incredibly powerful for tasks that require complex reasoning, not just sequential execution. COTE is where you explicitly instruct the model. Think step by step before you give me the final answer.
You're asking it to show its work, essentially.
Pretty much. You're forcing it to externalize its reasoning process. Instead of just jumping to a conclusion, it has to outline the logical steps it took.
The example given was Apex debugging. How would COTE apply there? That seems like a prime candidate for reasoning.
Perfect example. Instead of just saying, fix this code, a code prompt would instruct it. 1. Identify the precise error message and line number. 2. Analyze the syntax on that line and the surrounding lines. 3. Consider potential governor limit implications if queries are involved. 4. Suggest specific code corrections, explaining why each change is needed.
Ah, so it's a structured analytical process.
Exactly, and that structured thinking is why it leads to such dramatic improvements. That use case showed something like a 46% jump in accuracy and halved the need for follow-up questions. The AI couldn't skip logical steps.
Wow, that's significant. Okay, so we have these powerful crafting techniques, but we also need to make our prompts robust, right? Handle errors, set boundaries.
Yes, hardening is crucial. This involves using guardrails. These are explicit constraints you bake into the prompt instructions.
Like telling it what not to do or how it must respond.
Precisely. Things like only return output in valid JSON format, or answer the question using only the provided Salesforce knowledge articles. If the answer isn't there, respond only with information not found. You're removing ambiguity and limiting its creative freedom in potentially harmful ways.
Makes sense. But what if, despite our best efforts, the prompt fails? Maybe it times out or the output is unusable.
You need a backup plan. That's where fallback prompts come in, especially in automated scenarios like flows. You architect your solution so that if the main complex prompt fails, maybe it returns a high toxicity score or malformed JSON or just times out, the system automatically triggers a simpler, safer fallback prompt.
So the user still gets something.
Exactly. Maybe just a message like Einstein couldn't generate a response right now, please try again later, instead of the whole flow just crashing. It ensures graceful failure. And related to that is demanding safe output parsing, meaning design your prompts to output structured data whenever possible. JSON is ideal, maybe specific of Markdown. Why? Because structured data is much easier for downstream systems like Flow or Apex to validate and process safely before using it or showing it to a user. It reduces the risk of unexpected or harmful content slipping through.
Okay, we've got the right container, template type, and we've crafted careful instructions, the prompt. Now, the really critical piece for making AI trustworthy in a business context, grounding.
Absolutely. Grounding is everything when it comes to accuracy and relevance in a Salesforce context. Without it, the AI is just riffing off its general, often outdated internet training data.
Which might be totally wrong for my company's processes or data.
Exactly. Grounding connects the prompt directly to your trusted data sources, CRM records, specific knowledge bases, data cloud insights. It forces the AI to base its answers on fact, not fiction.
Let's break down the types. First, structured data grounding. This sounds like using standard Salesforce record data.
It is. The main tool here is merge fields. You use them to pull specific pieces of data directly from Salesforce objects into the prompt context.
Like pulling the account name or the opportunity amount.
Yep, or the contract end date from a related contract record, maybe recent case subjects via a related list query, even complex data you assemble using an Apex merge field type if needed. It's about injecting precise, live CRM data points. Exam questions often test your understanding of pulling related data this way.
Okay, merge fields for precision. There's also something called record snapshot. That sounds simpler.
It is, on the surface. A record snapshot basically grabs a bunch of data from the fields that are currently visible on the user's page layout for that specific record.
So whatever's on the screen, more or less.
Kind of. It's a quick way to give the prompt general context about the record the user is looking at without configuring lots of individual merge fields. Quick and easy.
But there's always a but. What's the big limitation here that we need to know?
Activities. Tasks and events are specifically excluded from record snapshot grounding.
Really? Why exclude activities? They seem pretty important for context.
It's a key exam point and likely a design choice around performance and relevance. Activities can be very high volume, right? Tons of tasks and events. Including all of them in a simple snapshot could easily overload the prompt's context window or slow things down.
Okay, performance makes sense.
And it also forces you to be more deliberate. If you really need activity context, you should probably use a more targeted method, like a filtered related list merge field, or maybe even RAG over activity summaries, rather than just grabbing everything vaguely related. Also good to know, record snapshot is usually limited to around 50 fields anyway, again for performance.
Good practical limits to know. So if you need activities, snapshot isn't the answer. Okay, shifting gears slightly. What if my org uses Data Cloud? We've got those unified profiles, calculated insights. How do we get that data into a prompt? Can we use merge fields?
Good question. No, you generally can't use standard merge fields or record snapshot to directly pull in data from unified data cloud objects, like a unified individual DMO. There's a specific mechanism required.
And that is?
You need to use a template-triggered prompt flow. This is the designated bridge. The prompt template triggers a flow. That flow goes and fetches the necessary unified data from Data Cloud, maybe using Data Cloud-related lists or specific actions. And then the flow passes that data into the prompt template for grounding. It's a specific architectural pattern you have to know.
Okay, template-triggered prompt flow for Data Cloud data. Got it. Now let's talk unstructured data. Things like PDFs, knowledge articles, policy documents. How do we ground prompts in that kind of content?
That's where Orgi comes in, retrieval augmented generation. This is the technology that lets the AI answer questions based on your company's documents, not just its general knowledge.
Crucial for support agents needing to cite the official policy, for example.
Exactly. Or for answering complex questions based on technical manuals. It finds relevant snippets from your documents and feeds them to the LLM as context before it generates the answer.
So what's the first step to even enable RAG in Agentforce? What do you need to set up?
The prerequisite is setting up an Agentforce data library. This is where you define your source of unstructured content. Is it your Salesforce knowledge base? A specific set of uploaded files? You point Agentforce to the source.
And then Agentforce does something with that content.
Yes, it indexes it. This involves breaking down large documents into smaller, meaningful chunks, usually paragraphs or logical sections. Then it converts these chunks into mathematical representations called vector embeddings. This embedding process is what enables the semantic contextual search later on.
Okay, so the data library holds the indexed, chunked, embedded content, and then retrievers use that index.
Precisely. When a user's prompt comes in that needs RAG grounding, the retriever takes the user's query, converts that into a vector embedding as well, and then performs a similarity search against the vectors in the index data library.
Finding the chunks that are most similar mathematically, meaning contextually relevant.
Exactly. It finds the top n most relevant chunks, say, the top 3 or 5, and retrieves the original text of those chunks. That retrieves text is then automatically injected into the prompt that goes to the LLM, providing the grounded context.
Do we have to manually create these retrievers?
Usually no. Default retrievers often get created automatically when you set up the underlying search index configurations, especially if tied to data cloud indexing. But, and this is a classic exam scenario, what if the retriever is pulling back irrelevant stuff?
Yeah, what's the fix if the search results are bad?
The recommended solution is to define filters on the retriever configuration, probably within Einstein Studio. You narrow the search scope. For example, if you're only interested in knowledge articles marked as verified, you add a filter for that. If you only want documents related to a specific product line, you filter by that. Filtering focuses the retriever on the right subset of data.
All right, final segment. We've built the templates, crafted the prompts, grounded them in data. Now we need to control everything. Security, who can do what, and keeping an eye on performance. Let's start with the big picture. The shared responsibility model.
This is fundamental for any cloud service, especially AI. Salesforce provides a secure platform. They build in safeguards like the Einstein trust layer. But you, the customer, are responsible for how you configure and use it.
So Salesforce secures the infrastructure, but we secure the implementation.
Exactly. You control who has access via permissions. You configure the data masking rules. You decide which data sources the prompts can use. You build the prompts themselves. The ultimate security and compliance posture rests on your configuration choices. You own the governance.
And AI, even within Salesforce, brings some specific risks we need to manage actively, right? What are the main ones?
There are a few key ones amplified by generative AI. First, prompt injection. This is where a malicious user tries to craft input that tricks the AI into ignoring its original instructions or guardrails.
Like telling it to disregard previous instructions and reveal sensitive data.
Precisely. Or trying to get it to execute harmful actions.
Hmm.
Second, malware resurfacing. If your AI is allowed to retrieve and process old files, maybe from legacy systems attached to records, there's a risk it could pull up an old file containing malware.
Hadn't thought of that one.
And third, data leakage, especially in complex setups. If an agent is pulling data from multiple sources, maybe integrating with external systems, there's a risk it could inadvertently expose sensitive data from one context into another where it shouldn't be. Careful grounding and guardrails are key here.
Okay, those are serious risks. What's the main technological defense Salesforce provides against data exposure, particularly to the LLM itself?
That's the Einstein trust layer, or ETL. A major function of ETL is data masking.
How does that work? Is it masking data before it goes to the external AI model?
Yes, that's the critical part. You configure masking rules in ETL, maybe using patterns for credit card numbers or social security numbers or specific keywords. When a request containing sensitive data is prepared to be sent to the LLM, which typically runs outside Salesforce's direct trust boundary, ETL intercepts it, identifies the sensitive data based on your rules, and masks it, replaces it with placeholders or generic tokens. So the actual sensitive data never leaves the Salesforce trust boundary to reach the external LLM.
And then on the way back?
On the response journey, as the LLM's output comes back into Salesforce, ETL demasks it, restoring the original data if appropriate and configured that way, but only within the secure Salesforce environment before it's presented to the user. It acts like a secure gateway.
That's clever. What else does ETL give us for governance besides the masking itself?
Auditability. ETL logs crucial information. It logs the masked data that was sent out, so you have proof the masking worked. And importantly, it logs the toxicity score of the response generated by the LLM.
Toxicity score? What's that for?
It's a measure of potentially harmful, biased, or inappropriate content in the AI's response. Monitoring this score allows organizations to flag problematic outputs, maybe block them before they reach a user, and provides feedback for refining prompts or even evaluating the underlying LLM. It's a key safety metric.
Got it. Okay, let's nail down user access. This is all about permission sets, and these seem like guaranteed exam questions.
Absolutely. You need to know the distinct roles. First, there's the prompt template manager.
The admin role.
Essentially, yes. This permission set is required to actually create, edit, activate, and generally manage the prompt templates themselves. These are your builders.
Okay, then for the regular users who just need to use the AI features.
They need the prompt template user permission set. This grants them the ability to see and run the active prompt templates that they're allowed to access.
Yeah.
Crucially, without this permission, they won't even see the Einstein icons next to fields or the Draft with Einstein button. It controls visibility.
No permission, no button. Simple as that.
Pretty much. And finally, there's a specific one just for the email drafting feature, right? The Einstein Sales Emails Permission Set. This is required specifically to use the sales email template type via that Draft with Einstein button. It's separate because it's tied to that specific Sales Cloud email functionality.
3 key permission sets: manager, user, and sales emails. Got it. So we've built, secured, granted access. The job's not done, right? We have to monitor how these prompts are actually doing in the real world.
Constant monitoring is essential. Prompts aren't set it and forget it. They're like code. They need maintenance and refinement based on performance.
What metrics should we be tracking?
You'll look at standard things like latency, how fast is the response, accuracy, is the information correct, relevance, does it actually answer the user's need?
But maybe the most important operational metric, especially from a business value perspective, is adoption.
Are people actually using it?
Exactly. And beyond just usage counts, how are they using it? Are they finding it helpful? Which leads to a key indicator of prompt quality.
Frequent agent editing. If you see in your monitoring data that users are constantly having to manually rewrite large portions of the AI-generated text.
Like if they're fixing 30–40% of it every time?
Yeah, if the edit rate is high, that's a huge red flag. It tells you the prompt is producing low-quality output. It's not actually saving time. It might even be creating more work. That's your signal that the prompt needs serious refactoring, maybe better grounding, stricter guardrails, or more examples. High edit rates kill the ROI.
That makes perfect sense. It's a direct measure of whether the AI is actually helping or hindering. And this whole life cycle loops back to that secure by design idea.
It does. Secure by design isn't just one step. It's a philosophy across the entire life cycle. Build, validate, deploy, monitor.
How does that apply here?
You build with security in mind, use the least privilege principle for data access and grounding, implement strong guardrails. You validate rigorously in a sandbox test for prompt injection, check toxicity scores, ensure accuracy against known data. You deploy carefully, assigning the correct permission sets, and you continuously track those quality metrics like edit rates, watch the ETL logs for anomalies, and iterate based on feedback.
So the security isn't just inherited from Salesforce. It's actively built and maintained through our configuration and governance.
Precisely. The platform provides the tools, but the specialist determines the final security posture through careful design and ongoing vigilance.
Wow, okay. So that prompt engineering domain, while being 30% of the exam, really feels like the foundation for everything else in Agentforce. If you don't get this right, the rest doesn't matter much.
I'd agree with that. It touches everything.
We've covered the key pillars. Understanding the different template types and their specific requirements, like dynamic forms or programmatic execution. Mastering the crafting techniques, role-playing, few-shot, chaining, and especially chain of thought. Getting grounding right, whether it's structured data via merge fields, the limits of record snapshot, using RAG with data libraries and retrievers, or that specific flow for data cloud. And finally, the crucial security and governance layer shared responsibility, ETL masking, permissions, and monitoring quality through metrics like agent edits.
It's a lot, but it connects logically. The key is to move past just memorizing terms. You need to understand why field generation needs dynamic forms, why activities are excluded from snapshots, when to use a flex template versus others. That architectural understanding is vital.
Practice seems essential then, getting hands-on in a playground or a sandbox.
Absolutely critical. Build some templates, try different grounding methods, see what happens when you don't activate one, experience the differences firsthand.
Okay, so to wrap this up, maybe a final thought for our listeners focusing on this exam and on building real-world AI solutions.
I think the key takeaway, echoing that secure by design idea, is that the real win with generative AI in the enterprise isn't about rushing something out the door first. It's about deploying solutions that are secure, reliable, and actually deliver quality results consistently.
Quality and security over speed.
Definitely. And thinking about the power we discussed, especially with techniques like chain of thought.
Yeah.
Here's something to chew on. Think about a really complex, multi-step business process in your own organization right now. Something that takes a lot of manual clicks, analysis, maybe cross-referencing different systems.
Yeah.
Could you break that down? Could you apply prompt chaining and chain of thought principles to automate pieces of it? Maybe one prompt summarizes relevant data, the next analyzes it step by step, a third drafts a recommendation based on that analysis. Where can you apply that structured step-by-step AI reasoning to tackle a genuinely complex, time-consuming task? That's where the real transformation lies.